Hello, everyone, and welcome. We're going to give individuals a few more, another minute or so to join, but welcome to our latest webinar with our friends from FICO. We'll be on another minute. Hello, everyone. My name is Bill Griffin. I work with Informs, and welcome to our latest webinar today in our series of sponsored webinars. We are joined by the team from FICO, who will be talking to us today about how Python modelers can increase ROI and business user engagement with FICO Xpress Insight. Today, we will be having about 45 minutes for our presentation from FICO, and then we'll reserve the last 15 minutes or so for question and answer. You can use the question and answer feature on the Zoom, and we will collect those questions throughout the meeting, and then when we're done the presentation, we will then have that 15-minute Q&A period. Today, we are joined by the team from FICO with Oliver Bastert, who is the VP of Product Management at FICO, Vladimir Roitch, and Johannes Mueller. Without further delay, I want to hand it over to Oliver, who can start our presentation today. Oliver?
Thank you, Bill. And welcome everybody to today's webinar. The outline will be as follows. I will kick it off really briefly, and then Vladimir will take us through a step-by-step, very hands-on demonstration of what we want to show today. So why are we doing what we are doing here? It's, we're seeing the following challenge within our customer and user base. So there's a number of great data scientists, operations researchers who develop their models, could be predictive models, could be optimization models. They work with them, they create results, but then at a certain point, it gets stuck in the science lab, if you will. Yeah, so there's no smooth transition from those models into the hands of the business as of today. And you can view that as two things. You can view that as deploying those models into full applications to the end user, and that's what we're going to talk about mainly today. The other way of deployment is obviously you want to take that model into a, could be a real-time decision engine or any kind of other in-stream use of your actual optimization or predictive model. But as I said, we are focusing on the first part. Our analysis shows that there's a variety of tools used to achieve something like deploying a model to a business user, but we couldn't find anything which would really be coherent and which would address all the needs of a modern enterprise to make such a seamless deployment possible. So our statement is basically those models are easy to create. Easy in the sense there's people out there who know how to do that. It's a hard task, but it's doable. We see that a lot. But the operationalization really is a challenge for most people. So we at FICO started, I think it was 9 years ago, with a product called Xpress Insight. And Xpress is an optimization product. So this is where we come from. And we developed this capability, but over time we found more and more adoption also in data science team. Started first internally in FICO. So we have a big data science team in FICO. They started using our products, and then it moved also on to the customers. So what do you want from such an application when you want to deploy a predictive or prescriptive model? You need first some data management. So we are providing very easy and very efficient data management, data editing, and analysis of your data capabilities. The next thing you want to do, you want to be able to compare data sets or sets of results. So you want to run some what if analysis with side-by-side comparison. So we have this scenario management built in. To execute your scenarios, you obviously need to execute the model. So we are providing optimization engines in Xpress, but you can use any other execution, Python, R, or other solvers if you like. Key, since optimization results and sometimes also predictive modeling results are not always obvious or easy to understand, you want some BI reporting included. We have various mechanisms for that, and for very complex reports, we are integrating Tableau into our stack. Then based on this scenario capabilities, you might also want to run more advanced simulation needs like baseline and challenger comparison. You want to run some sensitivity analysis, or you want to stress some factors in your model. This is all what we can do within the platform. And then towards the enterprise readiness, we have user management built in, complete solution management. You can host multiple solutions. You can scale out the execution capacity. So this is the full stack for you to deploy any kind of analytical model into a full business application. The workflow of development is as follows. What you expect, you develop your model, your application in an IDE. In that same IDE, you can design your user interface, all of which you're going to see in a second. And then you just press a button and this gets deployed into a full end user ready enterprise application. Before I hand over, I just want to quickly orient you in our stack. So FICO Xpress is most famous for its solver engines. So we started in 1983 with our first LP solver and have been in business since then. We've extended the suite of solvers to not only cover linear programming, mixed integer programming, and some quadratic and more complex algorithms, but also have a full nonlinear solver. And we also embed a constrained programming solver. So this is a very broad set of high performance solvers. On the modeling side, we have our own modeling language, Moselle, and we've always supported other APIs and modeling options for Xpress. And Python, we do also support for quite a while, but now with the last release, we are now able to also develop full applications in Python, and that's what we're going to focus on today. Just very quickly on the rest of the stack. So Xpress Insight, I showed you this before. And as you can imagine, when you run such an application, you need to execute optimization runs, predictive models, what have you. So we are having a scalable infrastructure behind the actual application. And we are now, with the upcoming release, enabling everyone to use that scalable remote processing capability directly accessible through our solver engines, through REST APIs, which we call the Insight Compute Interface. The development environment is Express Workbench with its view designer. And we, as well, our customers, are using this stack to build full solutions for optimization, but as I said, also for pure analytics applications. And with that, I will hand over to Vladimir to take us through the steps to create a full application purely based on Python.
Thank you, Oliver. Let me just share my screen. Okay, so like Oliver said, we would like to showcase the Xpress Insight suite by developing a very simple Insight app live and from scratch, hopefully in the next 40 minutes. So the plan is, first of all, I'm going to introduce the problem that we'll be solving, which is going to be a very basic portfolio optimization problem. So just a very simple toy example. So we'll also look at the data that we have available for us to build the app. And then I will skip ahead and give you a quick demo of the final app that we're going to build. And then after the demo, we'll go through all of the typical development steps which Oliver has mentioned. So we'll develop the Python code, and this will include formulating the optimization problem. And in the second half, we will develop a web-based user interface using the view designer capability of Workbench. So the app we'll create today is for a basic portfolio optimization problem. We have an investor who wishes to invest a certain amount of capital. And to do this, they're able to purchase shares to build a portfolio. And of course, naturally, they want to maximize the return on the investment. We have on the right here a table which shows the shares that can be purchased. So this will be our input data. For each share, we have the share type, so the industry, the expected return on investment, the risk category, so whether it's high or low risk, and the country of origin. So together with the objective, our investor also has a risk profile, and this is specified to us through constraints on the portfolio weights. So we have 3 of these constraints. We want to spread the risk, so that means no more than 25% of the capital should be invested in any individual share type. We want at least 45% in North American shares, and at most 1/3 into high-risk shares. So now I show you what the data looks like as a comma-separated value, so as a CSV file. And I've already done a little bit of pre-processing of the data just by indicating whether each share type is high risk or not, and whether it's North American or not. And this is just to save time for us in the demo. So as with any development or modeling project, it's very important for us to think about what data structures and data types we're going to use when we are modeling the problem. So on the left, I have extracted some parameters that I think the user may want to play around with, and they might want to generate different scenarios and then compare these scenarios before a final choice is made. And on the right, I have also indicated in the table the data types of the columns inside the CSV file. I've also added the new column here, so this fraction on the right, this will store the optimal portfolio weights after the optimization completes. It's also important at this stage to think about what are our inputs and what are the results. So I try to color code them here on the slide. So now we know what problem we're going to solve. I just want to give you a quick demo of the final app, just so that you can get a flavor of how it works and what features Insight provides. By the way, both the app and the source are part of the Express distribution, and there are, as part of the Express Insight Python developer guide, there are step-by-step instructions where you can actually build this app for yourself from scratch as well. Okay, so let me now switch to the web browser. So here I've logged into my local installation of Insight Server. And once we've logged in, we have the app home screen which shows a list of all the apps which have been installed. So I already preloaded some apps, some sample apps, which come as part of the Express distribution. And you can tailor this home screen to each individual user. For example, it can display only the apps which have been assigned by an administrator to whoever is currently logged in. So let's, as a first step, go ahead and upload a pre-built version of the portfolio optimization app. So it's just an ordinary zip file. And then we get this new card appearing on the home screen. So when we initially open the app, we have a scenario shelf here, which is currently empty. So let's go ahead and add a scenario here. And let's also load the scenario. So what this does is just initialize the input data. Okay, so now that the data is loaded, we can review it, we can modify it, we can play around with the configuration, and we can set up the scenario exactly how we want it. So on the left, we have the table which gets the values from the CSV file. And on the right, we have the configuration options for the risk preference. So once we're happy with the settings, we can just run the optimization. And the results appear on the bottom. So we have the optimal portfolio weights in a table on the left and as a chart on the right. So now what we want to do is we want to compare two different scenarios side by side to see maybe how the optimal portfolio differs. So I'm going to show you some of the scenario management features that you get from Insight, but this is all built in, so you don't need to implement anything yourself. So let us create a second scenario by cloning the first one. And let's also add it to the shelf. Okay, so now we have two series appearing in our chart. So when we clone the scenario, we essentially copied across all of the data from scenario 1 into scenario 2. Okay, so we have multiple scenarios on the shelf, but the one which appears leftmost, that is what we call the active scenario. And that's the one where all the data is displayed for in the UI. So let's make some changes to scenario 2. So for example, I want to change this to 20% and rerun the optimization. So as we can see, we now have two chart series which represent the different optimal portfolio allocations for the two scenarios. And this quite nicely and easily allows us to compare multiple scenarios simultaneously. We also have built in what's called the Entity Explorer, and this allows us to view the data entities of the app. So you can think of these entities as defining the data model or the data schema that the app operates with. So we have our scalars, which are the various limits we impose on the optimal portfolio. We have the shares fraction, which is the optimal portfolio weights. And we also have the input data itself. So as you can see, the initial values in this table come from the CSV file, but you notice that this table is editable. So once it's loaded, the user can make further modifications before the optimization problem is run. So just a quick note about this data model and the entities. So just like when you are designing an SQL database, you have to specify what your database schema is first. And the same concept applies here. So our data model is fixed. And this means that the names and the data types of all the entities in the data model must be predefined when we develop our app. And doing this has some benefits. So first of all, it acts as a kind of a documentation. So what are our input and result data? Secondly, IDEs such as Workbench or PyCharm can provide code completion, IntelliSense, and extra safety checks to help you develop your app. And you get this Entity Explorer out of the box because Insight knows what our data model is. And in any case, the user interface is always going to be tightly coupled to what our data model is. So we'll see this later on when we develop the UI, that View Designer is going to be able to provide specific suggestions to us and helpful wizards based on our data model. So that was a very quick demo of the app and the basic capabilities of Insight. But of course, Insight offers a wide range of other features related to scenario management, user management, execution, administration. And unfortunately, we do not have time to look at these today. So now let's delete the app and we can start to develop it from scratch. Okay, so now I switch to Workbench. And just before we get started, I want to say that there's a lot of examples and quick start templates which you can start off with when you're trying to learn about Insight. But I've just created an empty project for us to get started with to save time. Okay. So just before we get stuck in, I want to tell you a little bit about the folder structure which makes up an Insight app. So we have the attachments folder. And this is for any app attachments that you want to distribute as part of the app. We have client resources. So this is for client-side and view-related files. So we'll be creating some VDL views, but you can also have Tableau, HTML, JavaScript, and CSS. Next is our model resources. So this is for any files required for model execution. So for example, we have our shares CSV file in here. Next is the Python source. So this is where you can put your Python code files. So you can have as many Python files here as you want and the package structure, but the main file must always be called application.py. So at the moment it's empty. And the last XML file, this is what's called the Insight Companion XML file. And this just provides some configuration of the app. Okay. So now we can get started with developing the Python code for our app. And although you will see that Express Workbench does provide some very basic functionality for working with Python files, so you can get the syntax highlighting, you can actually run your project within Workbench, it doesn't really aim to compete with more mature Python IDEs like PyCharm. And for this reason, we really wanted to demonstrate that you can develop your Python code in any IDE that you already know and love, like PyCharm or Visual Studio Code, but then you can return to Workbench to develop the UI and to publish the app. So to this end, I'm going to now switch to PyCharm and we can start developing the Python code. Okay, so this is just the same folder opened in PyCharm, and we again start with our empty application.py. Okay, so our first step is to import the Express Insight package and assign it an alias of XI. And this package is available on PyPy as well as Anaconda. So what is an Insight Python app? Well, it's just an ordinary Python class. So in my example, I've chosen to call it Insight app, but you can give it any name you like. However, there are two things that you have to keep in mind. First, you need to extend app base, and this provides useful functionality to interact with the Insight server. So to get metadata, for example, or to read and write attachment files. And you also have to apply the app config decorator, and this allows you to specify some metadata about your app. So for example, you can specify the app name and the version of the app. So Insight will then pick this up and then it's displayed as we saw in the demo on the app home screen. So our next step is to now declare our data model. So each of the entities that make up the data model is going to be declared as a class attribute of the app. So as a first example, let's declare a scalar entity, which is going to represent the maximum fraction of capital that can be invested in all high-risk shares. I'm going to call it max high risk. So for the declaration itself, we use the Python type hints syntax with the colon operator. And here we've just declared that max high risk is a scalar value. We can also specify the default value to be 0.33. So this is the 1/3 we saw from the description. And as you saw in the demo, the user is able to change this value for a particular scenario. We also have to tell Insight the type of each of the entities in the data model. So in this case, the type of max high risk is going to be automatically derived from the type of the default value which we pass in here. So in this case, it's going to be floating point number. We can also specify an alias for the entity, which is a more user-friendly label that will be used if this entity appears in a table column header or in a chart or in the Entity Explorer. So next, let's declare the max per share entity, which represents the maximum fraction of capital that can be invested in a single share. And similarly for min North America, which represents the minimum total level of investment in North America. So far, we have declared 3 scale entities. Let's now declare an index called share IDs. And this will contain all of our different share types, such as the bank, software, telecom. So you can think of an index as a kind of the primary key of our data set. And if you've ever worked with Pandas Python library, then this concept of indices and what we'll see later on, series and data frame objects, will be very familiar to you. So in our example here, the share IDs index, it will contain string objects, and this is specified by the dtype parameter. And again, we can specify a user-friendly alias. So now that we have the index, we are ready to declare a data frame called shares. And this will store the input data as well as the optimal portfolio allocation. So we first specify that this data frame is going to be indexed by the share IDs index entity, which we have just created previously. And we can also now start specifying the columns that make up the data frame. So the first column is going to be the return on investment. This column will contain Xpress Insight real values. And we can also specify a format string, which will be automatically applied if this column is used in a table or in a chart. Similarly, we can declare the high risk column, which is going to indicate for each share whether it's high risk or not. So it's a Boolean type. And lastly, the North America column, which is going to indicate whether a share is North American or not. Finally, our output, or in Insight terminology, the result column called fraction, and this will represent the optimal portfolio allocation of each share. So by default, Insight assumes that all the entities that you declare are inputs. So what we have to do is to explicitly indicate that this fraction column is to be managed by Insight as a result entity. Okay. So we can now declare our final scalar result entity, and this is going to be the total return of our portfolio. And lastly, we have a constant class attribute, which is going to store the name of the CSV file that we're going to read the data from. So that's all for our declarations. Now we can start writing the processing code. So you've seen that from the demo, Insight has 2 main execution modes, the load and the run. So in the load mode, you typically initialize your input entities from any data source that you like. And then in the run, that's where the bulk of your computation and processing happens. So your input entities are automatically initialized by Insight, and you are responsible to populate the result entities. But also remember that in between a load and the run execution, the user is going to be interacting with your app, modifying the data of the input entities. But you don't need to worry about this because this is something that Insight manages for you. Okay, so how do we implement one of these execution modes? So we start with the load mode, and this is just an ordinary Python function. It has to be decorated with exec mode load, and this is just so that Insight knows which function corresponds to which execution mode. And you can also provide a description if you want to. So what do we do in the load? Well, we want to read in the CSV file and initialize our input entities. For this, we're going to use pandas library. And for that, we need to import it first. And now we can just use the read CSV function from that package in order to read the data file and assign the shares data frame, as well as to extract and assign the share IDs index. So next comes the run mode. And this is again, just an ordinary Python function, but this time we have the exec mode run decorator applied. So in this run mode, we will actually formulate and solve the portfolio optimization problem. So for this, we're just going to use the Express optimizer and the Python API it provides. But of course, you are free to use any one of the many solver and optimization modeling libraries available for Python. So once again, we start with importing the Express library. And we can now create a new
Vladimir,
object.
can I interrupt you for a
Excellent.
second? Could you try to change the font size? Just go to File.
Sorry, Johannes, it's not possible.
Okay.
Find our decision variables. So this is the fraction var, and we'll just put them all into a series object. So later on, we'll be using these decision variables to actually formulate our objective and constraints. Okay, so these must also be added to the problem. And now we can define our objective. So we want to maximize the total expected return of the portfolio. So we multiply each of the shares by the fraction of that share in the portfolio, and then sum up overall the shares to get the overall portfolio return. So that's the expression for the objective, but now we also add it to the problem and specify the optimization sense. So we want to maximize this. And next we deal with the constraints. So I won't go into detail about how these constraints are modeled, but I hope you'll get the general idea. So in each case, the constraint is going to be defined, and then we're going to add it to the problem. So the first constraint, we want to limit the total investment in the high-risk shares. The second constraint, we want to enforce a minimum investment in North American shares. The third constraint is going to ensure that we allocate all of our capital. So in this particular formulation, this also acts as our budget constraint. And we don't allow short selling because by default, all decision variables are assumed to be non-negative. Our fourth and final constraint is to limit the investment in any particular share. And that completes the formulation of the problem. So now we just invoke the solver. And after the solver finishes, we can extract the optimal solution. So this includes the optimal allocation of the shares in our portfolio, as well as the objective function value. So this is the total portfolio return. So that's it for the run mode. Express Insight package, it also provides an offline or development mode where you can run your Insight app without a connection to the Insight server. How do we add this? Well, we just use a standard Python idiom where we detect if this Python file is run as a script or by Insight. And if it's the former, then we run a test harness, which mimics a very basic Insight server. So here we've used also, if you can see, the sys package. So we just need to add it as one of the imports. And that concludes the Python code. So what we can do is we can run it to use the test mode. So as you can see, it all runs fine. We have the output from the solver, and we also have our print messages, which we have added as part of the code. So if we wanted to, we could publish this app to an Insight server at this point, but of course, there will not be any user interface. So we will only get the Entity Explorer. So now what we do is we will switch back to Workbench and start to build the user interface. Okay. So here I just verify that the content in application.py is exactly the same as what we've finished with in PyCharm. And the first thing that we need to do is we need to build our project within Workbench. Okay, so we have this build button at the top. And what this does is it allows Workbench to introspect our application.py file and extract the data model, which we have declared, and our execution modes. So this has successfully completed. And now we are able to start building the user interface for the app. To do this, let's create a new Insight view. We specify the name. And let's set this as the default view for the app. So once we have created the new view, View Designer has opened within Workbench. So I just want to tell you a little bit about the structure of View Designer. So in the middle, we have what's called the artboard, and this shows the structure of your app. Then on the left, we have the palette, and this contains the components which we're going to drag and drop to build the app. And on the right, we have the attributes to allow us to configure the components once they are added to the artboard. You can see there's also a hierarchical structure for our app. So we have page and we have section. Inside sections, we have rows. Inside rows, we have columns. And inside the columns, that's where our components go. So let's adjust some attributes. First, let's remove the heading. And let's also change the layout to fluid. And this is just going to make this whole section fill up the whole width of the screen. So now I want to recreate the layout that I showed you in the demo. So if you remember, we had a 2x2 grid layout. So that requires me to add 2 more columns. And let's also add the headings to the columns. So this one is input data. This one is configuration. This is results. And finally, we have scenario comparison. Okay, let me also make some adjustments to the size of these columns. So we'll make these 2 5 each. This one also 5. We'll make this one a bit wider because as we saw here, the chart compares multiple scenarios. So we just wanted to have a bit more space. And if you've ever done any web development with things like Bootstrap, then you will be familiar with this common concept of a 12-column layout. So as long as our columns add up to 12, we're fine. So now we can start building our table. Okay. So we have the table wizard, which opens and allows us to select which of the columns we want to appear in the table. So let's make also shares return editable. Okay. And let's also manually add the share IDs. So just select the set that this column should show us values from the share IDs. And let's also adjust the width of these columns. So just arbitrarily give these some different values. So the first one we give as pixels, second 2 are going to be as percentages. And then we leave the last one to take up whatever space is remaining. Let's also configure this table so that it's paged. So we set the pagination to paged, and we want 5 rows to appear on each page. So as you can see, View Designer actually gives us a kind of a schematic preview of the table because data may not be available yet. Next, for the configuration, we saw we had a form. So I'm going to drag a form component, and inside we had 3 fields. So the first field corresponded to the max per share entity. So the second one corresponded to max high risk. And finally, the third to min North America. Okay, so if you remember from the demo, there was a button here, and when it was clicked by the user, it ran the optimization problem. So let us add this button now. And change the label to run optimization. Okay. So now when the user clicks on this button, we want to be able to run the optimization problem. And for this, we can use the concept of actions. So actions are kind of general operations you can use to instruct Insight to perform an action in response to an event. So you can see a list of the built-in actions here. So we are interested here in the execute model. So we drag that to the artboard. So we have a new action group, and inside this action group, we have our execute model. So now we have the action group, we have the button. Let's link them together. So we add the event. The event should be click. And as you can see, all of the HTML events are available for us to use. And then we select the action group that we want to be executed. So in this case, the one that we just created. Okay, so now let's work on the results area of the app. So if you remember here, we had a label which told what the overall portfolio return was. So we're going to have 2 text labels here. The first one will be static text. And the second one will be dynamic text. And you can see we have a kind of a series of options which are commonly used, and we're interested in this one. And this will just take the scalar entity, whatever the value is, and invoke a number formatter. So in our case, we want to display the value of the total return entity. So by the way, this is just ordinary JavaScript you can put into this expression here. And now, lastly, we have the results table. Okay, so again, the table wizard opens. And in this case, we want to select shares fraction, so the optimal portfolio allocation. And again, just let's add our table column for the share IDs. Okay, and let's also modify the width so it matches to this input table above. So just the last charts section that we have left to do. So we drag a chart to the last column, and we have a chart wizard opens, and where again we can select what entity we want to display. So in this case, we want to display again the shares fraction. We can select different type of charts that we want. In this case, we stick with a bar chart, and we finish the table wizard. So as we have configured it now, this chart will display the portfolio weights, but only for the current scenario. But if you remember from the demo, we want this chart to compare multiple different scenarios. So what we want to do is to repeat the chart series for each scenario that we want to compare. So for this, we have a logic repeat, which we apply to the chart series. And we select the first option. So we want to iterate over all of the scenarios. And inside the loop, you get access to two things. So first I, which is the index of the scenario on the shelf, as well as S, which is the scenario object itself. Okay, so just the last step is we need to indicate for the chart series where the data should come from. So which scenario? So in this case, we just set it to the ith scenario. So we're almost done. We just have a very small usability issue with our app. So when a user first creates a scenario, there aren't going to be any results yet. So it would make sense that we hide this bottom row completely until after the user has run the optimization and the results are available. To do this, let's use an if logic block applied to the whole row. And now we have to specify what is the expression for this if statement. So in this case, we select this one. So this whole row is going to be shown only if results data is available. So finally, what we want to do is to display a helpful message to the user because they may wonder where are the results. Well, we just want to indicate that they should run the model first. So for this, we're going to create a new row, which is going to contain a message for the user. And the message will just be put in the heading of this column. But again, we only want now to display this row only in at a certain time. So for that, we again use our logic if block applied to the whole row. But this time, we want the negation of the condition. So when there is no results available, then we want to show this helpful message. So that's it. That's the whole interface. So you saw that View Designer is a very user-friendly drag and drop user interface creation tool. However, behind the scenes, there's a markup or VDL code which is generated. And we can see this code if we move to the code tab in View Designer. So there's a very seamless integration between the code editor and View Designer. So View Designer makes it very easy for you to create the interface, but it's also very useful to have this markup available because then you can easily put it into your version control system, and you can also extend with custom HTML, CSS, and JavaScript. Okay. So let's switch back to View Designer. And finally, we are ready to publish our app to the Insight server. So once we've set up this information once, then the publish becomes a one-click operation. Okay, so we can just click on this again. And this time it remembers all the settings. And now we can view the app. So let's just briefly verify that indeed the app works as we expected. Okay, so this concludes the demo portion. Let me stop sharing. And back to you, Oliver.
Thank you, Vladimir.
Great, thank you both. I've noticed that the FICO team's done a great job of answering a lot of the questions in the Q&A feature. If you have any more, please feel free to post them. We have a couple of other questions that we can get through to in a second. But please feel free to keep adding questions, and we will ask them as they come. We have a couple questions here. Oliver, are there other data structures that can be used with Insight?
Mm-hmm. I would like to pass that on to Johannes, who can probably best answer that.
So basically, you write Python code, which means you can use anything, any structures that you want in your Python code. But when you want to transfer data from your application to Insight or the other way around, then you have to use either normal Python scalars or Panda series and data frames.
Okay. How about visualization options?
You can either write VDL, which is the view definition language. Vladimir showed one example of that. You can use Tableau, and you can use anything which is supported by JavaScript, since the view definition language is simply an extension of HTML. You can just use any JavaScript library on the internet that you find.
Okay. What Python libraries are supported, and which version of Python is required to use?
So right now we tested version 3.7 and 3.8. There is no reason why 3.9 should not work, but we simply did not test it yet. In the next release, we will run all our tests, and then we also officially support 3.9. With respect to pandas, it should be version 1 or later. Yeah, that's basically the only real restriction. Python 3.7 or later, and pandas 1 or later.
Another question, how do you debug the Python code when an error occurs during execution of the scenario?
My recommendation would be to test-driven development, which means you try to make sure that you test your application before you run it in production or before you run it on the web server. We have nice features for running everything directly in PyCharm locally, and from there you can easily debug everything and all your tests. But when you run into a problem in the web server, so there are two options. You can either, for example, the easiest option is if you have PyCharm on the same machine as your web server, then you can just connect to the process. There's a button to attach your debugger of PyCharm to the process. And another option would be to write, to simply export the scenario and then import it and debug it offline. But this only works if your scenario doesn't do connections. Yeah.
Okay. A question came in on the Q&A. Can we use SciPy library in Python? Maybe.
Yes.
So that
you
right.
can
Okay.
use any libraries which you can install in Python. So this is a normal Python, and yeah, you can import anything that you want.
Okay. In terms of the next things for your product suite, what is next on your roadmap?
So right now we are working on performance improvements based on Apache Arrow. And the next thing is testing Python 3.9. Yeah.
Okay.
And there are a lot of internal and external requests, feature requests, and we will prioritize them. But now, let's see which one we implement next.
Very good. And one last, which version of Insight is required? Which version of Insight is required?
I think it's version 4.53.
Okay.
But I would simply install the latest version.
Wonderful. Okay, great. All right, I think that exhausts the questions that we had and the questions that came through our Q&A feature. Are there any last minute words from the FICO team?
Yeah, so two things. Thank you for the questions. I think there was one question which we answered in the chat already, which I would love to quickly pick up on, and that was, in what way does Python work better than a common language like Java or C++? So we're not saying that Python is the better language. I think what we figured out that there's the data scientists, operations researchers who adopt either algebraic modeling language for their modeling work, or Python, for example, as their preferred way of expressing models. And as you've seen, the data model is induced by the actual Python code. So it allows you to very quickly move from the model to the full application. And that's why we find, for the users we have in mind, Python is just the obvious choice here. Yeah, if you fancy Java or C++ and you like our scenario management backend, we provide REST APIs for the whole stack, so you can still use the backend if you want from any other language as well. Okay, and then just pointing out here, if you liked what you saw, if you want to browse more examples, go and download our community license. It's a fully functional version. It comes with Insight. It comes with our solvers. The solvers are size restricted, and you have some other limitations, but you can fully develop and test out the apps you build. And then we also have a community. So if you have more questions, if you want to discuss with us anything around our products or optimization, just come and visit us in our community. And with that, I would like to thank Vladimir and Johannes, Informs, and Bill. Thank you for hosting us here today. And thank you everyone for joining. So really appreciate it.
Yes, thank you team from FICO. Very good. Love the hands-on demonstration. I know the audiences do as well. Thank you participants. Thank you everyone for joining us today. Have a wonderful rest of your Monday or wherever you are in the world. And thank you and have a nice day.